Priyansi from DSC KIIT, and today we're going to be continuing with our tutorial series on the C programming language. Our topic for today is operators in C. So I'll just go on and read the formal definition and then we'll go over this step by step. So, what is an operator? An operator performs some mathematical or logical operation on the operand. And what is this operand? An operand is a variable or constant on which the operator is operating. So lots of confusing words, but let's unpack this. Uh, in maths, we consider an expression, right? Like a plus b. So in computer terms, here the plus becomes an operator because it is adding or performing a mathematical operation on the elements a and b. So according to the definition that we just read, a and b become the operands and plus becomes the operator. Now, uh, there can be any number of operands. So depending upon the number of operands, there are three kinds of operators: unary, binary, and ternary. So let's start by discussing what unary operators are. As the name suggests, a unary operator always acts on a single operand. Now, there are many types of unary operators, but we'll discuss the most basic and important ones. And I'll leave it to you as an assignment to go explore other operators like the not operator or the unary minus operator. Now, what we'll be discussing today are the unary increment and decrement operators. The unary increment operator increases the value of the operand by 1, and the unary decrement operator decreases the value of the operand by 1. Now, this operator, the unary increment or decrement operator, can be placed either before the operand, like we can see over here, or it can be placed after the operand, like we can see over here. If it is placed before the operand, then it is called prefix, and if it is placed after the operand, then it is called postfix. Now, again, lots of theory. Let's go over this step by step, and we'll discover what is the difference between prefix and postfix. Okay, so let's consider an example. Uh, let's consider a variable called a whose value is 3. Now, if I write an expression like this, b is equal to plus of a, where we are using a prefix unary increment operator, what do you guys think will be the answer of b? Like, what will be the value of b that is stored? You can pause the video, take a minute to think. Now, if you guys guessed the answer of b to be 4, you're absolutely correct. But what if I wrote something like, okay, and when we did this plus of a, before I move on, when we did plus of a, the value of a changed to 4. Okay. So what if I wrote something like b is equal to a plus plus, and now the current value of a is 4. Okay. So we all know that the unary increment operator increases the value by 1. But if it becomes 5, then what is really the use of postfix? So listen closely. The answer here would be b is equal to 4. Value that b is stored is 4 and not 5. The reason is this keyword, change before or after use. Now, change before use is what is associated with prefix. So first, when we are assigning the value of a to b, first it is the value of a is incremented from 3 to 4, and then it is assigned to b. But here, when we are assigning the value of a to b, first the value of a, which right now is 4, is assigned to b, and then it is incremented to 5. So if we declare another variable called c and simply assign it the value a, the value of c will be 5, which is the updated value of a. So this is a lot to take in, but play this part again if you don't get it, and try the same exercise with decrement, unary decrement operator. So I wrote up a small program for this, how this will look like in C code. And we're assuming the initial value to be 3. And let's just do a quick exercise where we'll try and predict the output of this sequence, right? So again, we consider, let me just move this side by side. Yes, okay. So here we consider a is equal to 3. First we are printing out plus plus of a. So the value of a will be 4, change before use, and then the value printed out will be 4. Cool. And then we have a new line character backslash of n, which which prints the next line in a separate new line rather than printing it side by side. Okay, so the next operation is, next print statement is minus minus of a, which first change before use, changes the value back to 3 and prints out 3. Now we have a of plus plus. Now the keyword again, change after use. So first we print out the value 3 and then increment the value of a to 4. And final operation, a of minus minus, which we again change after use, is first we print out what the current value of a is, which is 4, and then decrement the value to 3. Let's check out 4334. Let's check out if that will be the answer when we run the code. So yes, we are getting the output, right? Let's move on to binary operators. So binary operators, as the name suggests, always acts on two operands. And there are various types of binary operators, but we'll study about the most important ones. And as you proceed on with this course, you can point yourself out how many kinds of binary operators are there. You'll be able to recognize them. So let's start with arithmetic operators. Now these are our standard maths operations, which is addition, subtraction, multiplication, and division. Now there's a new operator that you can see here. This is known as the modulo operator. And what it does, it returns the remainder of the two operands that it is operated on. Now let's see some code for this. Okay, so here we are assuming two numbers a and b whose values are 5 and 2. So according to, let's see what the output would look like first. Okay, so first we can see that a plus b is 7, a minus b is 3, a multiplied by b is 10, and all standard outputs. Now something, now these are all standards, so I'll just remove them. We'll discuss about two interesting outputs that we got. A divided by b is 2 and a modulo b is 1. Okay, so what just happened is that we tried to divide an integer by another integer. So even though the result 5 by 2 is equal to 2.5, since it is an integer division, it got truncated to 2. So to make sure we get the output 2.5, we have to make sure that we are dividing floating points rather than integers. So once we change the data type, okay, you can see red squiggly lines over here. It means this is an error. I'll explain exactly why this is showing in just a few seconds. So we got so we are dividing 5.0 and 2.0 by sorry, we are dividing 5.0 by 2.0, and let's see what the output is. Oh, just a second, we have to change this to float. And yes, we are getting the value 2.5. Now let us discuss why we got an error as soon as we uncomment these lines over here. See, over A and B. Let me just quickly remove this. So You cannot, in C, you cannot perform the modulo operation on non-integers. It only has to be performed on integers. So if we convert these values back to integers, you'll see that the error disappears and we get our output. So one cool trick that I would like to show you is how to display the modulo operator in a print statement, because these are known as format specifiers. So how do we print out a modulo operator itself? Just use another modulo operator before it and you get the value like this. Okay, so moving on to relational operators. These operators tell us a relationship between the two operands. Now, this relationship can be anything: greater than, less than, greater than or equal to, less than or equal to, equal to. That is, whether two operands are equal to one another and not equal to. So let's see this in code. Okay, so instead of integers, we'll be using characters now. And if you're wondering how do we compare characters, well, this is very simple, because for every character, there is an integer value defined according to the ASCII table. Now, this is a standard table. I'll link it down about it in the description below, and you can go through it. The So what happens in the ASCII table is that every character has a specific integer value. So small a has an integer value of 97. Small b has an integer value of 98. I'll just quickly write it down. So since now these characters are converted to integer values, it's easier to compare them, right? So let's do that. Is a greater than b? Well, before that, we need to know the output of a relational operation on two operands. The output is either true or false. So A can either be greater than B or not be greater than B. So if it is greater than B, the output is true, and true is represented by 1 and false is represented by 0. So is A greater than B? No, A is not greater than B. So the answer that we should be getting is 0, which is equivalent to false. Let's just run the code. And yes, we are getting that. And is A less than B? Well, the opposite answer should be 1. Uh, Now, is A greater than or equal to B? We are getting the answer as 0. If, for example, both A and B were same, and the values of both would be 97, is A greater than or equal to B? The equal to part would have been satisfied, and we would get the answer 1. Sorry. And we will get the answer 1. And for the equality operator, A is equal to B. Yes, both are same. We get the answer 1. And again, not equal to B, we get the answer 0. Let's move on to logical operators. Now, logical operators help us determine a relationship between expressions. The keyword here is expressions because, as we know, relational operators help us find a relationship between operands. Now, I'll quickly show you what I mean is that, remember this from relational operators, A greater than B. Now, this is establishing the greater than operator is establishing a relationship between operands A and B. And this entire thing taken together becomes an expression, and a logical operator establishes relationship between two expressions like this. Now, what are examples of logical operators? These are and, the logical or, and the not operator. Now, let's see the code for this. So we'll be using the values from our previous example, which are small a and small b, whose ASCII values are 97 and 98 respectively. And what I need you to remember is, just like relational operations, the output of a logical operation always results neither true or false, so either 1 or 0. And here this entire expression on which the operator and is operating upon will be true only and only if these individual expressions, that are a less than b and a greater than B, if they are true individually, then and then only the entire expression will result in an output of 1. Otherwise, the output will be 0. So let's just put in the values and work it out. For our first expression, is 98 less than 9, sorry, is 97 less than 98? Yes, it is. So the output here is true. And for our second expression, is 97 greater than 98, which is false. So the output is false. So for our first expression, we got one true and one false, not both true simultaneously. So our result would be false. And the output should be 0. I'll just show you the output. So we got an output of 0, just like we predicted. And let's move on to the logical OR operator. So this entire expression evaluates as true if either one of these expressions, either A less than B is true or either A greater than B is true. So let's just put in the values and we'll see what the output will be. So first, A less than B is 97 less than 98. Yes. So we get a true. And by the definition of logical or we know that we just need any one of these expressions to be true in order for the entire expression to be true. So we got a true statement in a first try only. So no matter what the output of A greater than B will be, this entire expression will always evaluate to true. Now what C does is that it doesn't evaluate this second expression because it already knows that the output of the first expression is true. So it just goes who cares and it moves on. This is known as short circuit evaluation. Just a little bit of trivia. And so according to this, our entire expression should evaluate as true, which means the answer should be 1. And as you can see, we got 1 as an answer. Now, the final kind of logical operator is the NOT operator. Now, what the NOT operator does is that it takes an expression and whatever the value of the expression is, it just reverses that value. So, if the complements that value. So if the value of A less than B is true, then it just changes the output to false and vice versa. So here we know that the value of A less than B is true. So the entire expression including not will be evaluated as 0. Now let's move on to bitwise operators. Coming to bitwise operators, they are like logical operators, only that they work on bits rather than data types. What I mean by working on bits is like every information stored on a computer is stored in a string of bits. Like you probably heard this word when you talk about a 64-bit computer or 32-bit computer, like that. So when data is manipulated in the form of bits, it goes faster. And there are various use cases in the modern world, and we'll cover this topic in much detail later in the video. Right now, I just need you to know what the bitwise operators are. These are the bitwise AND, the bitwise OR, the bitwise XOR, the shift left operator and the shift right operator. Now, I don't want to go into much detail about how we will use it because we will discuss about this in the later video. So stay tuned for that. Okay, so moving on to ternary operators. Ternary operators, like the name suggests, always acts on three operands, and it is given by a question mark and a colon. So the entire ternary operation is represented as this. If a condition A is true, then we evaluate B, and if the condition A is false, then we evaluate C. So A, B, C are our three operands, and the question mark colon is a ternary operator. So let's just see what this looks like in code. So here I got two numbers, 2 and 3, and we are evaluating if A is greater than B. And if A is greater than B, then just print out A. And if A is not greater than B, just print out B. Now this actually is the expression for evaluating the max between both A and B. And if we just reverse our initial condition, that is A less than B, then we get the minimum value between A and B. Let's just quickly run this and see if we are getting the output. Yes, we are. The maximum is 3 and the minimum is 2. So what happening here is that it first the expression A greater than B is being evaluated, and we are asking the question, is 2 greater than 3, which it clearly is not. So then this A part is skipped and we go on to evaluate the second part, which is B, and we just print that output. So this is actually a really interesting use case for it. Not only can we find the maximum between two values, we can find the maximum between three values. And I'll quickly write down the expression for this and then we'll go over this one by one. So if you can notice, what I'm doing here is a nested ternary operation. So what is a nested ternary operation? A nested ternary operation is simply when I got a ternary operation within another ternary operation. And we'll quickly find out what this means. Okay, so what we are doing first is we are just starting out with two numbers, A and B. Is 2 greater than 3? Well, no. If, okay, we'll put in the values later. Let me just go over the entire expression then. Is A greater than B? Well, if it's A is greater than B, then we'll go on to check is A greater than C. And if you notice this entire expression over here, which is evaluated if A is greater than B, is within this entire ternary expression itself. So this is the uh, parent ternary expression, and this is the nested ternary expression, which is inside these. These both are nested ternary expressions, which are inside this big expression. So this is what I mean by nested ternary operation. So once again, if A is greater than B, we'll check if A is greater than C, and if A is greater than both B and C, then well we know the output is A. But if A is not greater than C, however A is greater than B, then we know clearly the output is C. And similar approach happens here also. If A is not greater than B, then we check if B is greater than C. If yes, then we get the answer as B. If not, we get the answer as C. And let's just check quickly if this works or not. So we should get the expected answer of 3. And yes, we are getting the expected answer of 3. Now, as an assignment, I leave you guys to figure out a nested ternary operation for finding the minimum value between A and B. Okay, and let's just move on to our final topic for today, which is operator precedence. So we are fairly confident about operators now. I would urge you all to go on explore some other operators like size of and the reference operator, which we'll learn about with much detail when we study about pointers. So lastly, coming on to operator precedence table, well, when we are given an expression, we don't usually operate on all operands at once. So there's a specific precedence. Just like the BODMAS rule in math, the brackets get evaluated first, and so on and so forth. We have something like that of a rule in C2. And I'll just link down PDF in the description below, and it will lead you to here, and this is the complete list of what operator precedence in C is like. So brackets, again, the brackets come first, and then we got the unary operators, unary increment and decrement operators, and then let's see find some interesting things. The logical not is here, and then we got addition, sorry, first we got multiplication, division and modulo, and then we got addition and subtraction, then we got some bitwise operators here, then relational operators, And you can see as you go down, further down, we got logical and logical or the last. And the ternary operator is assigned at the very end. Okay, so with this knowledge in mind, let's try and solve something. So I got an expression over here for us, and let me just quickly, okay. So this is our expression. Looks fairly complicated, but let's find out something. So go over this step by step. So I can see a logical NOT here. So from that we know in our table we saw this first, right? There are no brackets here or no increment decrement operators, but we found the logical NOT. So we know that it will be evaluated first. So now we are operating upon the operand 3. Now anything other than 0 is operated as true. So this is considered as true. So 3 would be true, which means that the value that it will be the output value should be 0. So since this is true and not changes the output, so then the value should be 0 here. So we got the expression now like 2 greater than 0 and 4 minus 1 not equal to 5 or 6. Now going back to our table, we can see that there are no multiplication, division or modulo. So we simply got addition and subtraction next. So let's subtract 4 and 1 then, sorry, 4 and 1, and this will result in 3. So our expression becomes 2 greater than 0 and 3 not equal to 5 or 6. Now after this, I'm pretty sure there comes relational operators, and we can find it here, greater than, less than, greater than, equal to, less than, equal to. So let's just go and evaluate that. So greater than 2, is 2 greater than 0? Yes, 2 is greater than 0, and the output of a relational operator is 1. So 1 and 3 not equal to 5 or 6. And if you saw this in the table here, there is the next is not equal to. So we'll evaluate that next. So what does the not equal to works on? It works on 3 and 5. Is 3 not equal to 5? Yes. So the output is 1. So again we get 1 and 1 or 6. Now this becomes pretty simple. First we evaluate 1 and 1. Both are true. Then we get 1. I'll just shift up the screen a bit. Okay. So we valued the value as 1 or 6. So 6 is also considered as true because anything other than 0 will be considered as true. So both of these are true and the final output is 1. And if you try to print out the value of this expression that I just gave, you will get the right, you will get the value of 1. Yeah, so we are done with discussing operators on C. If you are facing any problems, have any doubts regarding the assignment or just any doubt in general, reach out to us on our Twitter handles and follow Developer Student Club's KIIT Instagram and Twitter handles, and we'll be back to you with another video soon. Thank you.